Okay, look, here's the deal. This reactor is about to blow. I need your help. We don't have time to go into the details, but I was reacting ethylene and oxygen to make ethylene oxide. Bottom line, if we don't get this thing cooled down, big bada boom. Yep, this lab will look like a crater on the moon in about 10 minutes. So let's get down to it. We have 3 options. I'll take you through them and then I need you to decide. Damn! The temperature is already at 900 degrees. If it gets to 1500, I'm toast. Now, I remember a little bit from my undergrad. There's something called conduction. Here's the basic idea. If you have something hot and something cold, heat will flow from the hot one to the cold one. You know, like if you put a teaspoon into a hot drink. After a while, the teaspoon's handle will become hot. What we feel as hot or cold is called temperature. So temperature is like a measurement of the energy that the atoms inside the object have. If it's hot, it means the atoms are vibrating and spinning and jiggling about. The hotter it gets, the more they move. But when something is cold, it means the atoms are still, not moving much, just chilling. See what I did there? Anyhow, the hotter ones jiggle about more and smack into their closest neighbors, making them bounce around. They bump into their neighbors and so on and so forth. In this way, the energy gets transferred from the hot area to the cold area. This is called conduction. That's how the cold end of the spoon eventually heats up. Now, if we have something like copper, it's really good at conducting heat. But something like wood is really bad. This is known as the thermal conductivity. Metals are among the best conductors of heat. This is because of how the atoms are arranged and bonded together. Also the fact that most metals are a non-porous solid, meaning they have no holes in them. Wood, on the other hand, is made mainly of cellulose, and it's filled with tiny holes where water was transported in the original tree. I have a problem though. Looking around the room, I only have some wooden benches. Also, they're not the same shape as the reactor. It would be difficult to evenly cover the reactor and conduct the heat away. I also have a blanket. Yes, I sleep in the lab. Don't judge. I don't know. Would that work? What do you think? The blanket keeps me warm, so probably not. The temperature is still rising. We need to move fast. Okay, option B. I also remember something about radiation. The beauty about radiation is that it doesn't need a medium, meaning some physical thing to transfer the heat like a solid. Instead, it can even move through a vacuum like outer space. In fact, that's how the heat from the sun reaches us here on Earth. Radiation is electromagnetic waves, just like radio waves or light. Remember earlier when we talked about how when something is hot, the atoms are vibrating and moving about? Well, when that happens, they also emit electromagnetic radiation. Yep, that's right. Every object that has a temperature above 0 Kelvin is giving off radiation. But don't worry, it's not the type that comes from a radioactive metal like uranium or plutonium. Then we'd already be dead. Rather, think of it as the light coming from a heat lamp, like the ones used for a reptile terrarium, or the heat you can feel when something is glowing red hot, like a stovetop or a gas heater. Here's the issue. If I remember correctly, the heat radiated by an object is proportional to the fourth power of its temperature. This means that unless it's really very, very hot, like the sun, the amount of radiation it gives off is not that much. Oh no! Look at the temperature! To tell you the truth, I can feel the heat coming off the reactor. That must be the radiation. Okay. In that case, if we just wait long enough, the temperature will keep going up, the more radiation the reactor will give off, and it should become stable. What do you think? Should we just wait? I don't know. That seems risky. I know there is one last option, called convection. This one is related to why a hot air balloon floats up in the sky. Do you know why? Yeah, that's right. Hot air rises. What's happening is again related to that jiggling and vibrating of the atoms. But if it's a gas, like the air, the atoms bump into each other and then move away, spreading themselves further apart. What that means is it becomes less dense, so it kind of floats in the colder, denser air around it. You know, like a cork floats on water. So, naturally, when the air around a hot object heats up, it will rise up and move away. Sometimes you can see this as the shimmering effect on a hot road or above the sand in the desert. If I hold my hand above the reactor, I can definitely feel it. So it's happening right now. The problem is the air isn't very dense to start with, so it doesn't carry much heat with it. We call this its heat capacity. I'm out of time. If only I had something more dense. I don't know, like a liquid? Well, I do have that tap. If I open it up, I could run the cold water over the reactor. Okay, look, I'm going to need you to speak up. Which option should I use? Conduction, radiation, or convection? Water it is. Holy smoke. That was a close one. Thanks for your help. Disaster has been averted. At least now the reactor is cooled down and stable. So I'm safe for the time being. If you enjoyed this little adventure, let me know with a like. And until next time, when who knows what we'll be doing. Cheers.